We're going to look at the factors of higher degree polynomials. So first of all, parabolas, second degree polynomials. Remember, they look either like this or like this, depending on whether your a is positive or negative. Okay, and here's our standard form right here. And if we want this in factored form, we could factor it. And if down here, so here's my factored form. But if we remember our factored form, remember the stretch is out front. And if you look at our stretch, that vertical stretch, that a, technically since our factored form is y equals a times x minus r1 times x minus the second root, I really should take and factor out a 2 out of this in order to get the x alone. So really, if I wanted this in true factored form, it would look like y equals 2x plus 0.5 times x minus 3. So in this case, since I do factor out that 2, what it helps me find is the roots. And I can see them really quickly, because remember, it's x minus a root, x minus a root. So my two roots would be negative 0.5, or negative 1/2, and 3. Okay, another way I could do that is simply take the factors that I have right now, 2x plus 1 and x minus 3, and set those both equal to 0 and solve for them on the side. But, if you factor and get both x's to have a coefficient of 1, or where you don't see anything in front of them, then you can just simply see the roots. And technically what we do is we set y equal to 0 when we do find those roots. So I do have that example finished out right there. And if we do write it in factored form, it does help us graph it a little bit. So I can graph both roots. Obviously, we'd have to figure out where the vertex is and things like that. But if the roots are real numbers, we can see them on the graph, okay, because they're going to be x-intercepts. Remember, if they're not real numbers, so let's say we had a parabola like this, for example. What kind of roots are we going to have? Yeah, they're going to be complex, right, our imaginary roots. So in this case, if it doesn't cross the x-intercept, you would have complex roots. And remember, they would be conjugates of each other, which means if one was like 2 plus 3i, the other one would be 2 minus 3i. So if you're given the x-intercepts and a point on the parabola, you can write the equation of a second-degree polynomial, right? And we want to use factored form. Whenever we know the roots, we want to use factored form. So here's one root, here's another root, and here's a point on my parabola. So let's start with factored form. So y equals a times x minus r1 times x minus r2. So I got a root at 1 and a root at 3. So we'll say y equals a, x minus 1, x minus 3. And then we'll plug in a point. Remember, I can't plug in one of the roots, otherwise it'll just cancel everything out. So I'm going to plug in this point at 0, negative 1. So negative 1 equals a, plug in 0. And a would be negative 1/3. So we'd have y equals negative 1/3, x minus 1, x minus 3. And if I really wanted to, I could expand that out and get it in standard form or general form, whatever you want to call it. But we can leave it just like that. So now when we look at higher degree polynomials, like a cubic function, has a degree 3, how many roots do you think it's going to have? Yeah, here we go. We got 3 roots. So right here, and right here. And as you notice, they don't quite look the same as parabolas. It looks like it's about to be the same. It started down here and it came up and it started to be a parabola, but then it took back off up top to get a third root in there. Okay? And what happens is sometimes it might not even cross 3 times. It might do this. It might cross once and then come back down and then shoot up. So here's one root, and this technically has 3 roots, but what do you think the other 2 roots would be? Yeah, they would be complex roots, because the other part of that cubic function is not crossing the x-axis. And we'll look into that more once we get in a couple more sections. So what's important about these factors? Well, these guys would all be the roots. So I'd have a root at negative 1, I'd have a root at 2, and I'd have a root at 5, as we can see down here. And then if you notice that the difference between the blue and the red graph is that the blue graph has 1 for a vertical stretch, and the red graph has 2 for a vertical stretch. So the one with the red obviously, shoots up vertically a little bit more than the red one does, as you can see, or as the blue one does, sorry. And then if we would happen to negate that a value if we take a look at the green guy right here, what does that happen to do? Oh yeah, that reflects over the x-axis. Remember, because technically you negated the y, right, but got to divide it over back to our transformations chapter. Okay, so you can kind of tell all the different things that it does. So how many factors does a cubic function have? Well, should have 3, right? Sometimes they could be 2 complex conjugate roots if it only crosses it once, but there should be 3. And how many roots would that mean? Well, there's 3 factors. That means there's got to be 3 roots as well. And one thing to add to your notes, we already talked about a difference of squares, how to factor difference of squares. One thing we haven't talked about yet is difference of cubes and sums of cubes right here. So these are with binomial cubes. Right, so that means that the first term and the second term is cubed on both of them, and this actually we can factor whether it's a plus or a minus sign. And if you notice what it is, you take the cubic root, and those are going to be the binomial, and the sign stays the same, so minus, minus, plus, 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 and then it's always the opposite sign next, and it's almost like a perfect square trinomial, but remember in a perfect square trinomial, there's a 2 there. In this case, there's not a 2 here. Otherwise, it's almost the exact same thing. And there's always a plus sign in the back. Okay, so you just kind of have to come up with your own method. Remember that. That's how I try to do it. I try to remember sign stays the same, and then sign goes opposite for the next one, and then it's always a plus sign in the back. Okay, and I try to remember, oh yeah, here's my cubics, my cubic roots, and then it's just like a perfect square trinomial, but there's no 2 on the coefficient for the middle term. So whatever you want to do to help yourself remember it, that's what I try to do. But yeah, you got to get that memorized as well.